In this practice, find the weight functions for the parametric Bessel equations of order nu. X square y2 prime plus xy prime plus alpha square x square minus n square times y equals 0, where n is a fixed non-negative integers and alpha is a positive parameters. To find the weight functions, at first you need to convert the equation into the standard forms by dividing by the x squares. Then y2 primes plus 1 over x y primes plus minus n squares over x square plus alpha squares y equals 0. Then as a second step, we need to find the integrating factors. Factors can be discovered exponential. Integrals 1 over x dx. So you consider this part. It becomes exponential. Natural log x. This is equal to the x. So we find the integrating factor is equal to the x. Then you need to multiply the integrating factor in the equations. Then x y2 prime plus y prime plus minus n squares over x plus alpha square x y equals 0. Two terms combine into the single terms d dx x y prime plus minus n square over x plus alpha square x y equals 0. So by looking at this form of the equations, you can easily find r is a x and q is correspond to the minus n square over x. To consider the parametric Bessel equations, actually n is a fixed number, n is givens, and the lambda is a alpha squares, and p is a x. General solution is given by y equals c sub 1 j sub n alpha x plus c sub 2 y sub n alpha x. This is a general solution of the differential equations. If you look at the form of the R, if the boundary condition is given at the x equals 0, then R0 equals 0. So this case is actually singular Sturm-Liouville problem. So in this case, at the R is approaching to the 0, y and r is approaching negative infinities, so cannot satisfy boundary conditions. So for the j sub n r is approaching the 0 when the n is not equal to the 0. When the n equal 0, j sub n is approaching to the 1. So you have to take n is a non-zero values. Solution is given by c sub 1 j sub n alpha x. So boundary conditions is given by a sub 2 j sub n alpha b plus b sub 2 alpha j sub n primes alpha b equals 0. So this alpha is actually comes from the derivative of the j sub n alpha x. This is, if you consider this is equal to the y, you apply the chain rule. So this is equal to the alpha. So it becomes alpha j sub n primes alpha x. So from the boundary conditions, we determine alpha sub I. So to satisfy this boundary condition, you can find the alpha. So once you have alpha sub I, you can find the lambda. Lambda sub I is given by the alpha sub I squares. So this is eigenvalues. Orthogonality relations is expressed 0 to the b. So boundary, inner boundary at x equals 0, outer boundary x equals b, and the x j sub n alpha sub I x. and then j sub n alpha sub j x dx. So this x is correspond to the px. So we discovered px is a x. And then this is equal to the 0. When the alpha sub I is not equal to the alpha sub j. So we use a different value of the alphas in these equations. Okay, this is the answer to this practice.